Hello everyone, good morning. And my name is Criselda, Mujeres, Pescadero. I'm teaching in Second Graduate Technical School, and today I'll be having a demo about states of matter, and this is one of the requirements for Khurusapha. Morning everyone.
Morning, teacher.
How's your day today?
It's great, teacher.
Yeah, good.
Yeah.
Have you eaten your breakfast?
Yeah, I had a very good breakfast earlier, teacher.
What did you eat for breakfast? Is your
I
Melvin?
just had bread, teacher. American breakfast, teacher.
Wow. How about you, Ali?
I had just bread and some fried chicken and fruits.
Wow.
Healthy.
Healthy breakfast. How about you, Harold?
I have rice and egg with
Wow.
milk.
Okay. All right. Anyway, do you have any idea of our lesson for today?
States of matter.
States of matters. Our lesson for today is all about states of matter. Do you have any idea what is states of matter?
States of matter.
States of matter.
I believe it's something that is around us.
Okay, very good.
It's like the
Oh, I remember.
solid,
Yes.
liquid, and
Gas. Is that
gas.
Yeah, I think so. It's something that we use it every day.
Use every day.
Yes.
We touch every
We
day.
touch, and yeah, maybe it helps us to go somewhere, just like that.
Okay, very good.
I still remember my teacher in elementary. She said that matter is anything that occupies space and has a mass. Is still true, teacher?
Yes, that is correct. Okay, very good. Now, let's move on to our learning objective. So, our objective for this lesson is to understand how matter can change from one state to another. So, when we say matter from one state to another, what does it mean? In your own idea, what does it mean? Like, matter can change from one state to another, meaning from solid and change to liquid.
Oh, okay.
Oh,
Sure.
maybe something like it can transform from one
Object.
form, and
One
it can be changed to another.
I think to support this idea, teacher, like I observe teacher when we have ice and it turns into water. Is that what it means?
Yes, that is correct.
Okay.
Okay. And do you know what are the states of matter? Do you still remember the 4 states of matter?
Four?
Four.
I thought three.
So before we had 3, but now they updated. We have 4. Do you still remember?
I only know the 3.
Solid,
3, solid,
liquid,
Liquid.
and gas.
gas. And we have one more.
One more.
They added one more states of matter.
Frozen.
Frozen,
Is it in the blood?
blood,
Blood.
I think I come across with that teacher, but I don't know which one.
you're
is
not
that.
familiar with it? Okay. Alright, don't worry, we are going to tackle that later. So, now let's move on to this one. So these are the states of matter we have.
Plasma.
So we have
Solid.
Liquid, gas, and plasma.
plasma. So we have plasma.
Oh, okay. I remember plasma now.
Yes, plasma. So you mentioned earlier that you've learned this when you were in your elementary.
Yeah.
Now, when we say solid, what does it mean?
So it has a
Hard.
definite shape, teacher.
And it must be hard.
Must be hard,
Okay.
like something that you can touch.
Yeah.
Okay, very good. How about liquid?
Liquid.
Water.
Water.
Something that we drink.
It follows the form of its
Less.
container.
Yes.
Less
Ah.
atoms, and molecules, and
Okay, less atoms and molecules. And
compared to solid.
okay, all right. How about gas?
Gas.
Gas, like the air we breathe.
The air we breathe.
Okay.
Oxygen.
Oxygen.
They're not compact.
They're not
Yeah.
compact.
Like
Yes.
farts?
Fart.
Oh.
Very
Your
good
farts?
example, classmate.
Yeah.
Okay, how about plasma?
No idea.
Okay.
Plasma might be plasma. I know plasma.
It's like,
what
it's like a
comes-
plant.
Yeah,
Plants?
plasma. What comes in my mind is like it's in our blood, but
Yeah.
right? Is it plasma? Do you have plasma? Do you have?
Okay, so plasma is the scientists added plasma in the states of matter, and it characterized by a partially ionized containing electrons and electrons and ions.
I remember now, teacher.
Yes.
Yeah, plasma. Like I told you earlier, come across that one.
Okay.
So like what you said, there are free moving ion and electrons.
Yes, free moving
It's
of
like
ions
space.
and
Yeah, we can observe in space like the sun.
electrons. The sun.
Yeah, the lightning.
Yes.
Is it connected with the ones like when we like it has a positive or negative charges?
Ionized.
Yes.
Ionized.
Yeah, ionized and electrons.
Is it the one that can generate electricity?
Yeah. Yeah. I remember they're highly conductor
Yes.
of electricity.
That's why the examples are sun.
Sun. Yeah.
So we
The
can get
lightning.
energy from the sun, and then lightning,
I
and then
see.
the stars.
Now it connects.
Connects. Classmate.
Yes.
All right. Okay, now let's move on to the next one. So states of matter. So Harold, can you please read this one? First sentence.
Based upon particle arrangement.
Yes, states of matter based upon particle arrangement. So when we say arrangement, what does it mean? Arrangement. So like particle arrangement.
Organized.
How they are organized. How the particles are organized.
Yes, how the particles are organized. What else?
How the particles are packed together in
Packed.
a container.
Like a pattern or something.
Okay.
Or are they loose? Or
Okay. Or compact.
Yes.
Okay. Next, Ali, please read the second sentence.
Based upon energy of particles.
Okay, so based upon the energy of particles. Energy of particles. When you say energy, what does it mean?
Is it a one that has positive and negative charges?
Yes.
And once you combine them, they can generate electricity.
Yes. Okay.
Or energy.
Honor.
Okay. Yes, Harold, you're saying something.
It's like the sun.
The sun.
Yeah.
Okay.
The energy of the
So we
sun.
can get the energy from the sun. Okay. Melvin, please read the third sentence.
Based upon distance between particles.
Okay, so based upon distance between particles. So in your own understanding, what does it mean? This sentence means what?
It has something to do with the first statement also, teacher, how they are like
The distance of the molecules.
molecules from each
From
other.
each other.
The matter.
Okay. You're so
Like that.
smart. Okay, this one. What do you observe in this circle here?
Moving.
Moving.
Particles.
Moving of what?
Moving.
Of particles.
Okay, moving of particles. So it says here that matter is made up of particles which are in continual random motion. So that's what they call kinetic theory of matter. So do you still remember when you say kinetic, what comes first in your mind? Kinetic.
Moving.
Moving.
Yeah, motion.
Motion.
Energy in motion.
Energy in motion. So that's why they call it kinetic theory of matter. Why? Because of
Particles.
particles.
They're constantly moving.
Yes, constantly moving. Why does it? We can see here that there's green, red, white, and blue.
That's the color of light,
Color of the lights.
which is red, green, and blue.
Uh-huh.
Pigment.
Pigment. Okay. Ali.
I think those are the positive and the negative charges of atoms.
Okay. What else, Melvin?
I don't have any idea, teacher.
Okay. see that in our next slide. Okay, solids.
The red.
Yeah. So as you can see on the screen, particles of solids are tightly packed, vibrating about a fixed position. What does it mean? Like this?
Oh, okay, teacher. So it's like even for solid, teacher, though we don't see it like moving, but the particles that compose the solid actually still move. But because they're tightly packed,
packed.
they're just vibrating.
Yes.
Oh, okay.
That's right.
I just realized.
So let's say if you're going to put your phone and then someone's calling,
Yeah.
and then if you put that in your vibration with the vibration mode,
Yeah,
so
we tried that.
since you put it on your table
So,
and it's solid, so it's like they move together.
They vibrate.
They vibrate. It vibrates.
So can you give me an example of solid? Ali?
Me.
Oh, Harold?
Chair.
A
Chair. Okay, what else?
What I like most in our house, I think our bed.
Okay.
I like to sleep.
Huh?
Oh, is it solid? Yeah, my bed.
Is ice
The bed is
solid?
solid.
And sometimes the bed vibrates.
It
I know
does.
it always vibrates.
Yeah, when you go to bed and sleep.
No, because they're solid, teacher.
Yes.
Yes, they're compact.
Compact, and then since
Yeah.
the particles cannot really move around, so they just vibrate.
Yeah, exactly. They vibrate unless they're broken.
Yes.
Right.
Yes.
But this time solid is like compact, so that's why the particles are intact, just like in the picture.
Okay.
So maybe just one big common example is this one. This is compact, right?
Yes.
Yeah. Yeah, it's compact, concrete. Unless if there's an earthquake, then it just only moves.
But still solid.
Yeah, it's still solid.
Okay, thank you so much. How about
We have mutual understanding, teacher. Yeah, I just support the idea of my classmate.
Thank you.
Okay.
Ice, teacher.
Ice?
Ice.
Ice is solid or no?
Ice
Liquid.
belongs to liquid. So
Ice
when-
is ice.
Solid.
Ice.
Ice.
solid?
Sorry, it's ice is solid.
Solid and liquid.
Solid and liquid in
Yes.
itself. So ice belongs to solid. Now, do you have any questions for this?
Well understood.
Okay, so take note. Particles of solid are tightly packed, vibrating about a fixed position. Meaning, again, fixed position. Solids have a definite shape and a definite volume. When I say definite shape, what does it mean?
It has its exact
Okay.
shape, teacher. You can really tell that, yeah,
Yes,
which shape a solid has.
yes. So, definite shape and definite volume. Definite volume.
Meaning it occupies space, right?
It's given.
It's given. Okay. Alright, next. States of matter liquid. Can you please read, Ali?
Particles of liquids are tightly packed, but are far enough apart to slide over one another.
Okay, very good. So particles of liquids are tightly packed, but are far enough apart to slide over one another. So as you can see on this picture, so what do you observe?
Compared to solid earlier, teacher, the molecules of the liquid are moving.
Yeah, they're
Yeah.
moving. But see the distance compared to solid. Solid is compact, like the particles are just in one place. But that one, actually they are moving, but the particles are just there close together. Right?
Still close
Still
together.
close together. But they can move.
Yeah. Oh, yeah, they're sliding, right?
They are far enough apart to slide over one another. So compared to solid. Okay. And then liquids have an indefinite. Before solid, they have definite shape. But now, liquids have an indefinite shape and definite volume. Why?
It doesn't have a shape on its own, teacher. Like,
Okay.
yeah, it just follows the shape of the container.
The container.
So wherever you put it in, so it just like follows the shape of its container.
Example.
Like the water, you placed it, you put it on in a glass.
Okay.
So the shape is also in
So,
a form of glass.
all right.
Yeah.
Thank you. Is glass solid or liquid?
Solid.
The glass solid.
Solid.
So,
All right. Ali.
Um,
Example of liquid?
Maybe beer
Huh?
or milk. You know,
Milk.
we all drink milk, right?
Okay.
Yeah, especially kids. So when you place when when you place a milk inside a glass,
Uh-huh.
of course it goes with what is the form of the glass. If it's like square, rectangle, whatever, right? It goes with the along with the shape, but and definite volume. It's just like the amount of liquid that you place in the container or the glass is still the same. It doesn't change.
it still occupies
Yeah,
space.
but it occupies space.
Okay. All right. Thank you. How
I
about
really
Harold?
like milk teacher.
Gas.
Okay. There's a question here.
Gas.
Mr. Ali likes
Milk.
He likes milk.
Yeah.
Why?
Milk.
It's healthy. maybe.
Yeah, of course we're living, which I choose to stay healthy. Yeah. So yeah, it's a matter of choice.
Okay. Thank you.
Next to water.
It's
Yeah.
worth following teacher.
Yeah.
Very good.
Okay. Let's move on to Harold.
Gas.
Gas.
I mean gasoline.
Gasoline.
Yeah.
Gasoline.
Yes.
No,
Gasoline?
Gas.
The petrol. Petrol.
Yeah.
Petrol.
It's is it gas? Gasoline. Gas.
Gas. Gas. It is gas.
Tricky, tricky.
Gasoline.
But petrol,
Sorry,
they're
gas.
petrol.
Petrol. Petrol.
Yeah.
Yeah.
It's actually liquid.
Liquid.
Yeah,
Instead
it's
of the
liquid.
vapor.
Liquid.
And once it's consumed with heat, I think that
Yeah.
it's being like how do you say that?
They change into gas.
Change
into
gas.
gas.
Ah, okay, thank you. All right. Now let's move on to the next one. Okay, this one states of matter, which is gas. What do you observe compared to the two matters earlier?
They're free moving particles.
Yes, they are free moving particles. That's why.
That's why when you fart,
Yeah.
yeah, even for example, when a person is farting just right away from you, yeah, yeah, it goes through it wherever, right?
You will know it like instantly.
Yeah,
Because they move so fast.
Oh, okay.
it does occupy space, does it? No, it's free. It yeah, from the picture, it's free moving, right?
Oh.
Yeah, they move freely.
This class is fun, teacher. I'm like,
Milton just do not fart.
okay.
Okay.
Teacher, I won't do it today, but last night I had a hard time.
Oh my god. It has smell, but you won't know who farts, right? Or you won't know the name.
Why you don't know, or why you won't know who they are?
Oh, but I have a way to determine who farts,
Who farts?
teacher.
Really?
Yes.
How do you determine that?
The first to complain.
Yes, that's what I'm about to say. The first person to complain, right?
Yes.
Normally.
Normally.
Yes.
Oh, okay. Thank you so much for that. Now let's move on. Gases have an indefinite shape and an indefinite volume. Why? Why do you think so?
It's freely moving.
Yes.
Yeah.
It does not form any shape, and we actually barely see that, teacher. So
Yeah.
how can we tell what's the shape?
I think from the scan, is it true, teacher, that from the scan, fart is color green?
I didn't know that.
This,
I'm not sure of
from
that.
this, so does fart have
Yeah, that's
color?
right.
Or it depends on the kind of fart?
I don't know.
Or maybe a fart that goes along with with particles.
Oh, yeah.
Right?
With the solid one.
Yes. Yeah, and that's why it has color.
Color. Oh, it will
Ah.
depend. Oh, it will depend.
So, teacher, gas and solid can mix together.
Yeah.
Maybe sometimes.
They can go
Yes.
together.
Yes, they go together.
Even liquid.
Di ba?
it would depend.
Ay,
Sometimes you have the solid and then followed by the liquid.
normally.
And then gas.
Usually, I think that's the usual thing that follow, after one another, after this thing, the other one will follow.
Yes.
And they're very close together.
Yeah, okay.
Alright, thank you. Let's move on to the next one. Okay, so these are the phase changes. So we have the description of phase changes. We have solid to liquid, and that is called melting. Yes, so solid to liquid, that is melting, and then heat goes into the solid as it melts. So that's the heat movement during the phase change. Now, liquid to solid, that is freezing. And then the heat movement when heat leaves the liquid as it freezes. Example for solid to liquid.
The ice.
The ice, what else?
The ice cream.
Why do you think the ice cream melts?
Because it's made up of water.
Because of the environment.
The heat.
The heat?
The temperature.
Temperature. When there's a change of temperature from cold to warm or
Uh-huh.
to heat, so it melts. Oh, Melvin, are you liquid or solid?
I'm solid. I have my own shape.
I see. But when you are moving, when you have sweats,
Oh, okay. I melt.
you melt.
Yes.
When you eat ice cream, it melts too.
Yes.
I see.
Oh, it only tell teacher that I'm hot.
Yeah. Based on the temperature, right?
Yeah.
Because solid turns liquid if there's a change of temperature. That's why it melts.
Liquid to solid, freezing.
Freezing.
Example.
Sorry. Wow.
Liquid to solid.
Yes.
The very basic how water turns to ice.
Mhm.
Yeah. When you put water inside the freezer, then it freezes.
Alright, very good. So that's an example of liquid to solid. How about liquid to gas? So the term for phase, we have vaporization, which includes boiling and evaporation. So example, what's an example? Liquid to gas.
When you boil the water,
Mhm.
and then it will form like steam.
Okay.
So I think it also vaporizes.
Okay. What else, Ali?
Liquid to gas. I think after you take a bath, you're wet.
Okay.
I mean, nothing but wet. Yeah, your body's wet. And when you go outside, maybe you use a blower to dry your hair. Then I think those water,
For your hair?
Vaporize.
Okay.
Is it the right word?
Okay,
Yeah.
yes.
So liquid to gas.
How about Harold? Example of liquid to gas.
The boiling.
Boiling.
Or the process of like water
Okay, the process of water from liquid to
from the cloud, from the sea, the cloud.
okay, evaporate.
Evaporation.
Okay, evaporation. Okay, so heat goes into the liquid as it vaporizes. How about gas to liquid? Example,
Condensation.
condensation. Can you tell me what is condensation, Ali?
From the meaning,
Yes.
this is where it leaves the gas as it condenses.
That's right. Heat leaves the gas as it condenses. Give me an example, Melvin.
Water dew,
Ah,
like
okay.
early morning teacher.
Yes. Okay.
We can observe that watery in on the leaves of the plant.
Yes.
So I think it's from water.
From the
Gas.
Yes.
Yes, and then because of the temperature.
Yes. That's right. Okay. Ali, another example of condensation aside from water dew.
Condensation. I can't think of the best example, but I would agree with Milvin. Yeah.
What about this one, teacher? If we put in cold water in the glass,
Mm-hmm.
and then in just like a short period of time, you will observe like there are like water outside the glass.
Yes.
Is it still condensation?
Yes, that's right. That's right. still example of condensation. Okay, now solid to gas, sublimation. Example.
Example. The one we put inside our toilet. How do
Okay.
you call it, classmate? Albatross.
Alba, mothball.
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 Yeah.
Okay.
Okay.
It's sublime, right?
Ah.
It's from the solid form and it turns to gas.
What do you call it? The
Magic
scented,
ice.
scented thing. We put inside that we can, so that you're
Yeah, it's like, yeah, it has a smell, right?
yeah.
Mm.
And you hang it to contain or neutralize the smell in your toilet
Yes,
after you
yes.
fart, or maybe you Yeah.
After you
yeah
relieve yourself.
relieve yourself.
What do you call it? Albatross.
Albatross is the brand. I
The
guess.
brand.
The brand, the brand. Sorry, we cannot afford that. We don't use mothballs.
The ice, the magic ice. No.
The ice.
Carbon ice.
Carbon ice, especially snow. Am I right? Snow?
No, another alternative for the ice
Yeah.
t-shirt. What do you call it?
Okay. It's just like when like you open your refrigerator and then there's a smoke that comes out from the freezer. It's the solid, right? So how come that there's an air, like you see smoke coming out? Yeah, I think it's sublimation.
Sublimation. Okay.
That's right, thank you. So, sublimation is the heat goes into the solid as it sublimates.
Okay.
Okay, so now let's move on to this one. But what happens if you raise the temperature to super high levels between 1000 degrees Celsius and 1 million degrees Celsius? Will everything just be a gas? What do you think?
Yes.
Yes. Why?
Liquid.
Maybe
Liquid.
some turns liquid.
Maybe some will turn to liquid. So will everything just be a gas?
I think no.
Why?
I think just like gold is solid,
Uh-huh.
but when you apply pressure, it turns liquid.
Okay.
And when there's no heat, or if you move it to another lower temperature, then it solidifies again.
So you mean it depends?
Yes, I think.
Depends the matter. Okay. How about Melvin?
I'm thinking, teacher, if the gas are already free moving,
Uh-huh.
right? What else could happen if you put more temperature into it? And then maybe you can hardly feel or see the gas anymore.
Anymore.
Yeah.
Okay. Alright. How about Harold?
Maybe like it turns back to the solid state.
Solid state.
Yeah.
Okay. Alright.
The cave, something like that. I don't know.
It depends maybe.
I can think of the sun.
The sun, yes.
Yes,
Yeah.
the sun.
The sun
sun's-
still does not consume itself. It keeps on burning, right? So for how many thousands of years, the sun is still sun. So
Okay.
it's
Alright, very good answer. Now let's move on to this one. Plasma. So a plasma is an ionized gas. Example, we have stars, sun, lightning. And then it says here that, Ali, please read.
a plasma is a very good conductor of electricity and is affected by magnetic field.
That's right. A plasma is a very good conductor of electricity. So we have ions and electrons. And plasmas, like gases, have an indefinite shape and an indefinite volume. Agree?
Yes, teacher.
And then plasma is the common state of matter. Why is it common? Why is it common?
Common state of matter. When you say common, maybe it's everywhere.
It's
You can find-
everywhere.
you can find it.
Okay, so let's have a review about the states of matter. We have solid, liquid, gas, and plasma. So when we say solid, that's tightly,
They're tightly compact, And because they're tightly compact, the molecules just vibrate. They're not moving that much. And
Okay.
then do not move from that place. And they solid has definite shape and volume.
Okay, very good. How about liquid, Ali?
Liquid, they're close together with no regular arrangement. They as well vibrates, move about and slide past each other.
That's right.
So
And
they conforms with the shape of the object where you place them, and they don't have definite shape because they just follow what an object you place the liquid into.
Okay. Thank you. And gas, Harold?
Gas is separated with no regular patterns or arrangement
Alright.
and move freely.
Okay, they move freely. And then plasma has no definite volume or shape and is composed of electrical charged particles. Thank you so much for that. Now we'll have our board work. You have to come in front and draw the distance of the states of matter. I'm looking for, no, I'm looking for this one. Okay, now, can you come here, Ali, and draw the solid,
The arrangement of the
the arrangement of the particles? The arrangement of the particles. Solid.
Right, solid.
Yeah. Yes.
Okay, bigger.
Okay.
Wait.
And can you explain it to your classmates?
So solid. See, the particles are packed together, and they don't move. Instead, since they are packed just like this, so they only vibrates, right? Like what is our example earlier? Yeah,
That's the bed.
yeah, it vibrates.
Vibrate.
Yes, it moves, but all together.
Yes, all
And just
together.
vibrates.
Okay, thank you. Melvin, please draw the arrangement of the particles of liquid.
Liquid.
Okay,
This
thank
one is
you.
right.
And explain it to your classmates.
So this is how I draw the particles of the liquid. They are close together but not as compact as solid. So the particles can just like move about, slide past each other, and then a little bit the particles can move a little bit compared to the solid.
Okay, thank you. Harold, gas.
This
Okay.
so it's like they stuck with each other and they can move freely along the space here. So this is gas.
Thank you so much, students. And for the plasma has no definite shape and
Volume.
yes, and volume. It's composed of electrical charged particles. So we have positive and
Negative.
negative. Positive and negative ions and electrons. Now, I have a question here and you have to answer. Question number 1. When a solid changes to a liquid, it's called melting. True or false?
Solid to liquid.
Yes.
Teacher, it's melting. It's true.
That's correct. Number 2, the particles in a gas are packed tightly together. True or false?
Me,
Yes, Harold?
false.
False. That's correct. Number 3, solid takes the shape of the container that they are in. True or false?
False.
False. Very good. Next, when a solid reaches its melting point, it becomes a liquid.
It's true.
True. Very good. Condensation is when gas turns into a liquid.
True.
True. When heated, chocolate changes into a solid.
False.
False. Why? It
Not
becomes-
liquid. Yeah.
When you heat ice, it becomes liquid. True.
True, teacher.
Okay. And the last question. The boiling point of water is 1,000 degrees Celsius. True or false? Boiling point of water.
No.
False.
Yeah, what's the
100.
boiling
100.
100. Very smart. Now, we'll play Kahoot.
Kaput.
Okay. Ali, can you help me? We'll play Kahoot this time. And then please. Okay. Kahoot.
All the way, classmates, all the way.
Okay.
Alright. So we have 20 questions here. 20 questions. We'll play Kahoot this time. Let's see if you know the answers. Let's see if you learned something with me. Okay, classic mode. Okay, please copy the pin.
Here.
Okay, pin.
Kaput. Oh, so we can actually scan the code.
Yes. You can scan the code or you can copy the number. Ban Ban.
Oh, slow. Teacher, the
Tarhu.
sounding experience so
Harry.
slow.
Okay, now let's start. Question number 1. States of matter.
Teacher, does it have a sense?
Yes. What terms describes the temperature at which a substance can change state from liquid to gas?
Gas.
Boiling point, freezing point, melting point, specific heat.
Huh?
Liquid to
Which substance?
What term describes the temperature at which a substance can change state from liquid to gas? Ah, okay. Next. Scoreboard. Ban Ban. What is the mixture of how much space an object takes up? Matter, weight, mass, volume.
Ah, yes.
Takes up space. Okay, volume. Okay, next. Which substance takes the shape of its container and has a definite volume? Definite volume. Solid, liquid, gas. Very fast. Next. Okay. Identify the states of matter found inside of this object.
Is it?
On. I think so.
Wow, gas. That's correct. Oi. Okay, next. Identify each state of matter from top to bottom. Solid, liquid, gas, solid, solid, gas, liquid. So fast. Okay. Wow. What term describes the temperature at which a substance can change state from solid to liquid? Solid to liquid.
Melting points.
It's melting point. Okay. What term describes the temperature at which a substance can change state from liquid to solid? Liquid to solid. Yeah, that's correct. It's freezing point. Next. The most common state of matter in the universe is found in the sun. What is it? Oh, very smart. Okay. Water is being released from this teapot in which state of matter?
It's only 5 seconds.
Wow. Okay, what will happen to liquid if it is heated? Expand, melt, contract, freeze.
Why this one takes
So it's
longer?
heated. So the particles.
We have to wait one more answer. Okay, expand. Very good. Wow. Okay, next. The amount of mass in a certain volume matter is mass, volume, density, matter.
Mass.
Density is the correct answer. No one got the correct answer. Matter is defined as anything that has
Phase changes and mass.
volume and mass. Very good. Wow. Clouds form when invisible water vapor in the air blank into visible water droplets of ice crystals. Evaporates. The correct answer is condenses. Blank don't have a definite shape, instead they fill up any available shape. Gas is the correct answer.
Nobody got the correct.
Okay. Which substance has a definite shape and volume? Definite shape and volume. So fast. It's solid. Okay, next. At what temperature is the melting and freezing point of water? At what temperature? Wow. No one got the correct answer.
I thought it's melting.
Okay.
Yes. The process by which a solid changes directly to a gas is called. Solid changes directly to gas. The correct answer is sublimation. Just one correct answer.
Oh no.
Only Melvin is not the correct answer. At what temperature is the boiling point of water?
Oh, this is the one.
Yes. So fast, and that is correct. The process by which a gas changes directly into solid is called. Gas changes directly into solid. Gas to solid. Deposition. Last question. The process by which a gas changes to plasma is called plasma. Ionization. Oh, very good.
Yay, it's the winner.
Let's see. It's Van winner, Tarhu and Harry.
Yay! All you are very competitive.
Very competitive students.
Yeah, there must be one winner, right?
Yeah.
And the
Yes.
second and the third must follow.
Yes.
Okay. So before we end our class this morning, we'll have a recap. Now, who can summarize or who can give me what you've learned today? Yes, Melvin?
Well, today, teacher, we learned a lot, meaningful information from the matter. So matter is anything that occupies space and has a mass, and it has 4 states,
Okay.
starting from the solid. So the solid has compact particles, and then the particles cannot move much, and they just vibrate.
Okay.
But solid has definite shape and a volume.
Okay.
And the next one is liquid. Liquid compared to solid is a little bit loose, but the movement is still like tight. Okay, solid particles just light about, do not move freely. Solid do not have a shape of its own. It follows the container which is put in, like what my classmate said earlier, but it still have the volume.
Yes.
Then another one is the gas. The gas particles are freely moving. They don't have a shape of its own, and they don't have a definite volume. And then the last state, the state that we learned today is the plasma. Okay, it's what is it? The electrons are ionized, and they are really moving, and they are highly conductor of electricity. So we can observe them from the sun, lightning.
Okay.
That's it. I think I missed also a little
Yes.
information, and we also learned about how a state changes from one form to another.
Yes.
So when like a solid changes to liquid, what do you call it? That's name. Solid to liquid.
Melting.
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 What do you call the process of changing gas into liquid?
Gas to liquid.
Liquid.
What is that arrow?
Condensation.
Liquid to gas.
Liquid to gas.
Evaporation.
Liquid to
Condensation.
gas.
Yes, evaporation.
Evaporation. And the last one is gas to solid.
It's
There's another one. Deposition.
Deposition.
And then solid to gas is sublimation. We learned a lot.
Very good, Melvin. Okay, more? Any addition?
Harold.
The same. Copy.
The same.
He's saying, okay, I think, yeah, Melvin has mentioned everything, and that summarizes our lesson today. So we are being surrounded by matters. The matters does not only come in one shape or it conforms actually, like the liquid, it conforms with the shape where you place it, and solid, yeah, we walk on solids, right? Here, or everything that we can touch, these are solids. And the gas, though we cannot see it, but sometimes we feel it, right? We smell it.
Okay. That's right.
Yeah. And the fourth one is the plasma. Okay, so we as well feel it through the sun, and maybe we see it through the lightnings. So there's an energy that goes along with when we see the lightning when it strikes, right? We see the lights, and there. That's why there's the energy, because it composes of positive and negative charges, so it creates energy, right?
Right.
Even
Correct.
yeah.
Sir, I'd like.
Very good. So that's all for this class. Thank you so much, everyone, and have a nice day.
Thank you, teacher, and goodbye.
Bye.
Okay, tayo.
Come on.
Salamat kayo, Sir Harold, Sir Melvin.
Okay.
Ali.
Bye.
Yes.